Hi there, a bit more further maths for us here. Again, looking at vectors and again looking at angles and between lines and planes. I say again, last time we looked at the intersection between lines and planes, and today we're looking at the angles between lines and planes. Now, this is actually the angle I want. I'm not sure if I turn my pen on, we'll soon find out. Yes, I have. That's the angle I want. Usually, actually, I'll write it theta, so I might as well write it theta there as well. And a bit weirdly, I'm going to find this angle here up here, usually written phi or something like that. So we get the wrong angle effectively when we do this method, and I'll show you that in a bit. So this is the rule when we're doing it. So the angle up here is my phi, and I'm going to find that angle by mistake almost, and then the angle I actually want, as I say, is the angle between the line, which is this line here, and the plane, which is kind of going in this direction according to this. So that's what we're trying to find. We're trying to find that. And we're going to use this 90 minus phi trick. So this is finding angles between a line and a plane. Now, there are occasions as well that I want to find angles between two planes instead. And it says here the angle between two planes is equal to the angle between their normals. So as long as we can find angles, and which is basically dot product, then we'll be fine. We're going to try to use the dot product to do this. So if we have two lines, you may recall from A-level maths, we might not have even done this in A-level maths yet, we'll have to remind myself. But I basically use the dot product between the two direction vectors. So you've got a line which might be r equals a plus lambda d, I call it d1, and we've got another line, r equals a different letter, a different point, so I might as well call it b plus mu d2. And to be honest, the a and the b vectors or the points on the plane don't matter. What I do care about though is the direction of d1, the line that goes that way, and this line goes this way. I care about those, and if I can dot these two things, I can find the angle between, which is going to be called theta. So we just said then we're going to do the line and the plane. It's probably best thought of as thinking this is the plane. That's my plane. And coming out of the plane, of course, we have a very dodgy line there, but the normal vector. And we have a line which intersects this plane. And that's the angle I want to find. But unfortunately, my method finds that. So that's phi, and the one I want there is my theta. And it says we've got this direction vector of this line. This is my d. I've got my normal vector coming out here. That's my n. It says we're going to dot d dot n. And if you can't remember how to do that, don't worry about that. We'll just remind you how to do that in a bit. And if you've got two planes, you do n1 dot n2. So you imagine a plane. I don't think this is my best ever representation of a plane. And we've got another plane kind of coming through it. Almost. Actually, it's better than I expected it to be. There's my two planes, and I want this kind of this angle here at which it's striking. And it says if I just dot the normal vectors from the equations, I will get my theta there quite happily. So that's what I'm going to try to do. So here's what my first one. It says the angle between the line and the plane. And so notice what I said just now. Angle between the line and the plane is d dot n. That's what I'm going to do. So what's my direction vector? For my line, my d is this bit here, the thing that's attached to the lambda, 3, 3, 2. My normal vector is 5, minus 1, and 1. And notice the 7 doesn't matter, the 4, 0, 7 doesn't matter. That doesn't affect the angle. It might affect where it hits, but it doesn't affect the angle. So I'm going to dot these. And this is where you're going to have to remember what we've done in normal vectors in normal maths, and hopefully we've done it by now, but if we haven't, I'm going to tell you what it is now. Basically, the rule says if you do a dot b, that's equal to the magnitude of a, the magnitude of b, cos the angle in between. And I can use this fact to work out the angle. So let's do d dot n. Let's just physically times them together. 3 5s are 15. 3 minus 1 is minus 3, and 2 1s are 2. So if you work that out, you get 14. So now I know that d dot n is 14. I'll find the magnitude of a. Well, in this case, magnitude of d. So magnitude of d is the square root of, and I square all the numbers. That's 3 squared is 9, plus 3 squared is 9, plus 2 squared is 4. So that sounds like 1822. Root 22 for the first one then. And then I've got the magnitude of n. So the square root of 5 is 25. The square rather. Did I say the square root of all of them? Who knows? The square of 5 is 25. The square of minus 1 is 1. The square of 1 is 1. So that's root 27. And so what I basically now do is I can say, well, using this formula here, my d dot n, which I know is 14, but I also now know it's magnitude of this, cos of the angle in between. Root 22, root 27, cos theta. So, I say cos theta, this is cos phi, because that's what I've said this rule gives me. It gives me the wrong rule, the wrong angle. So cos phi is 14 over root 22, root 27. I get my calculator. Now I'm going to do it in degrees. 14, check that it is in degrees, yes, divided by square root of 22 and root 27 as well. And I get 0.57. So inverse cos of that is 54 degrees. Now remember, this is phi. It's 54.9 degrees. And so therefore my theta, my angle I want, is 90 minus that. Minus the 54.9. Just don't want to make any daft mistakes at this stage. Haven't got so close. 35 and a bit. 35.1 degrees. Good. And that's the angle I hope this now says. 35.1. So next one says the angle between two planes. Find the acute angle between these two planes. And you again, if we just go back to say what I did say you could just dot the two normals. I was looking at the wrong picture then. Dot the two normals and it will give you the angle you want. So that's actually one less job to do at the end, unlike last time. So what are the two normals? My first normal here is 4 minus 1 and 5. My second normal is 1, 1 minus 3. I want the angle between them. Well, I just dot them. So 4 minus 1, 5. Dot 1, 1 minus 3. And I suppose this is the equivalent of what we were doing before, isn't it? n1 dot n2 equals the magnitude of one times by the magnitude of the other times by cos of the angle in between. And this time it is the angle in between. It's cos theta. Yeah, so what you need to do is obviously multiply this out. 4 ones are 4, minus 1, and 5 3s are 15, or minus 15. So what's that give me? It gives me minus 12, I think. And of course, I now need the magnitude as well. So the magnitude of n1, what is it? It's the square root of 4 squared is 16. 1 squared, well, minus 1 squared is 1. And then 25, which is 1742, root 42. And I've got magnitude of n2, the second normal, is the square root of what I've got. I've got 1 and a 1 and a 9 when I square all those. That's root 11. So I can now put all these formulas together. Obviously, this is n1 dot n2, which I got minus 12 when I did the multiplied the dot product out. And then that's equal to root 42 times by root 11 cos the angle in between. Or said differently, I suppose, cos theta is minus 12 over root 42 root 11. And therefore theta, let's do that with my calculator. So I've got inverse cos of negative 12 divided by the square root of 42 and 11. What do I get? 123 degrees. And it does say at the top it wants an acute angle. So good job I spotted that. 123.9. So acute angle is 180 minus that answer. So even though I said this gives me the right angle that I want, not a right angle, but the angle that I want, in this particular case, it gave me an obtuse angle. And of course, I wanted an acute angle. So I've effectively found the other side of that angle. So I think the actual angle they want is 180 minus it, which I get 56.1 degrees. Done on my calculator. So that's 56.1 degrees. And you can see that picture is actually quite good because 56 is the one they wanted. My initial way of doing it found the other side of that intersection. And that's it. So we've got a little 10-minute video. And again, I think it's quite a nice, gentle topic. Thank you very much.